Aquaculture methods and practices. Freshwater and brackish water environments. Content standards. The learners demonstrate an understanding of the concepts and skills in fisheries. Performance standards. The learners perform the skills in fisheries following safety precautions. Learning competency. Discuss occupational safety and health, OSH, hazards in fisheries. Discuss advantages and disadvantages of organic aquaculture. Identify different aquaculture methods and selected practices. Determine the area and depth requirement of aquaculture facilities. 1. Describe freshwater and brackish water aquaculture practices. 2. Compare different aquaculture methods and determine benefits and limitations. 3. Demonstrate understanding through collaborative activities. Review. What are the three main types of aquatic environments used in aquaculture? What is cage culture? What is raft culture? Freshwater environment. Freshwater culture refers to raising and breeding aquatic animals, fish, shrimp, crab, shellfish, etc., and plants for economic purposes by the use of ponds, reservoirs, lakes, rivers, and other inland waterways, including brackish water, which play an important role in the aquaculture industry. Composite fish culture. It is a system in which 5 or 6 different species of fish are grown together in a single fish pond. Fish with different food habitats are chosen so that they do not compete for food among themselves. This ensures complete utilization of food resources in the pond. Example species combination. Different feeding zones. Surface feeder, catla, column feeder, rohu, bottom feeder, marigal, grass feeder, grass carp, omnivore, common carp preventing competition and ensuring efficient resource use. Catla, mainly eats zooplankton. Rohu, Labio rohita, feeds on phytoplankton and vegetation. Marigal, Serinus marigala, feeds on detritus, decomposed vegetation, and other organic matter. Grass carp, Ctenopharyngedon edella, a herbivorous fish, mainly feeds on aquatic plants and grasses. Common carp, Saprinus carpio, an omnivorous fish, feeds on both plants and small aquatic animals. Monosex culture refers to the culture of either all male or all female populations, a sought-after approach in aquaculture. The advantages of monosex population culture and details the mechanisms to achieve it based on different modes of sex determination and sexual differentiation. How is it achieved? Manual sorting. Separating male and female fish by hand. Hormonal treatment. Using safe hormones to produce only males or females. Genetic methods. Breeding techniques to create only one sex. Example. Tilapia farming often uses all male fish because males grow faster. This is concerned with the culturing of individual species of fish. Only one species of fish is raised in the pond. Example. Culturing only tilapia or only milkfish. Advantage. Easier to manage and monitor growth. Air-breathing fish culture. Shallow water bodies with poor oxygen content is used for culturing air-breathing fish species such as channa, clarias, heteropneustes, etc. Predator-prey culture, Mural tilapia, is also undertaken in shallow waters and in swampy areas. Here, predator fish like murrels are cultured along with their prey fish, tilapia. Brackish water environment. Fishpond culture. Pond culture, or the breeding and rearing of fish in natural or artificial basins, is the earliest form of aquaculture with its origins dating back to the era of the Yin dynasty, 1400 to 1137 BC. Over the years, the practice has spread to almost all parts of the world and is used for a wide variety of culture organisms in freshwater, brackish water, and marine environments. It is carried out mostly using stagnant waters but can also be used in running waters, especially in highland sites with flowing water. A. Culture species. Commonly raised species in freshwater ponds are the carps, tilapia, catfish, snakehead, eel, trout, goldfish, gourami, trout, pike, tench, salmonids, palaemonids, and the giant freshwater prawn macrobrachium. In brackish water ponds, common species include milkfish, chanos, mullet, mugel sp, and the different pennaid shrimps, Penaeus monodon, P. orientalis, P. merguiensis, P. penicillatus, P. semisulcatus, P. japonicus, and M. ensis. The more popular species for culture in marine ponds are the sea bass, grouper, red sea bream, yellowtail, rabbitfish, and marine shrimps. In Asia, where the bulk of world production from aquaculture emanates, fish ponds are mostly freshwater or brackish water, and rarely marine. In China and most of the Indian subcontinent, pond culture is traditionally dominated by freshwater species, mainly the carps, usually in polyculture and/or integrated with animal husbandry. In Southeast Asia, fish ponds are predominantly brackish water, with milkfish and pennaid shrimps grown either in polyculture or in monoculture. 2. Site selection. Proper site selection is recognized as the first step guaranteeing the eventual success of any aquaculture project and forms the basis for the design, layout, and management of the project, SCSP, 1982A. For fish ponds, especially those to be used for coastal, brackish water aquaculture of high-value species like shrimps, site selection is critical and should be given utmost attention. Guidelines for selecting a suitable site for coastal fish ponds. 1. Soil quality. Preferably, clay loam, or sandy clay for water retention and suitability for diking. Alkaline pH 7 and above, to prevent problems that result from acid sulfate soils, e.g., poor fertilizer response, low natural food production and slow growth of culture species, probable fish kills. 2. Land elevation and tidal characteristics, preferably with average elevation that can be watered by ordinary high tides and drained by ordinary low tides. Tidal fluctuation preferably moderate at 2 to 3 meters. Sites where tidal fluctuation is large, say 4 meters, are not suitable because they would require very large, expensive dikes to prevent flooding during high tide. On the other hand, areas with slight tidal fluctuation, say 1 meter or less, could not be drained or filled properly. 3. Vegetation. Preferably without big tree stumps and thick vegetation which entails large expense for clearing. Areas near riverbanks and those at coastal shores exposed to wave action require a buffer zone with substantial growths of mangrove. The presence of Avicennia indicates productive soil. Nipa and trees with high tannin content indicate low pH. 4. Water supply and quality. With a steady supply of both fresh and brackish water in adequate quantities throughout the year, the water supply should be pollution-free and with a pH of 7.8 to 8.5. 5. Accessibility. Preferably readily accessible by land, water transport, close to sources of inputs such as fry, feeds, fertilizers, and markets, fish ports, processing plants, and ice plants, and linked by communication facilities to major centers. 6. Availability of manpower for construction and operation. C. Pond layout. The layout of the pond system depends on the species for culture and on the size and shape of the area, which in turn determines the number and sizes of ponds and the position of the water canals and gates. A fish farm is considered properly planned if all the water control structures, canals, and the different pond compartments mutually complement each other. SCSP, 1982A. A complete fish farm has nursery and grow-out ponds and, in some instances, transition ponds for intermediate-sized fish, shrimp, all of which are properly proportioned and positioned within. Milkfish culture in brackish water ponds in the Philippines follows the traditional practice of providing for nursery, transition, and rearing operations. In some cases, formation ponds are used for additional growth or stunting of fingerlings prior to stocking and rearing ponds, Fig. 2. The nursery ponds comprise about 1 to 4% of the total production area while the transition and formation ponds constitute about 6 to 9% of total area, Camacho and Lagua, 1988. It has been suggested that a similar progressive culture scheme be adopted for shrimp pond culture when no supplementary feeding is practiced. For growing to a medium size, a two-stage progression composed of a nursery pond, NP, and a rearing pond, RP, is adequate. Fig. 3. For growing to larger sizes, a three-stage progression composed of nursery, transition, and rearing ponds is recommended. Fig. 4. ASEAN, SCSP, 1978. Two. Cage culture. The culture of fish in meshed boxes placed in water is called cage culture. It is an intensive method of aquaculture and practiced on areas where there is sufficient water movement. It is done in rivers, estuaries, and seas. It is originated in Kampuchea about 200 years ago, and originally cages were used to transport fishes alive from capture area to the market area. Types of culture. Cage. Cages in lake. Fish pen. Cages in the ocean. Construction. Components of a fish cage. Frame. It can be made of wood, plastic, or steel. Generally, plastic is used. Floats. They are made up of empty barrels or polythene balls. Sinkers. They are made of stone, concrete, or metal. Net. 3 types of nets are present: inner net, outer net, and cover net. It is made up of nylon, welded mesh, or woven split bamboo. Structure of a cage. The cage may be square, rectangular, circular, 6-sided, or 8-sided. Generally, square and rectangular cages are preferred for culture. The normal size of the cage is a 20 to 60 meter cube. Types of cages. Fixed cages, installed in running water. Image from fish farming expert. Floating cages, lakes, rivers, and offshore water. Submerged and movable cages, areas affected by cyclone. Feeding. The water movement brings in nutrients and natural feed. In addition, artificial feed is also given. Examples: rice bran, fish meal, and soybean cake. Pen culture. Cage culture and pen culture, both terms are often used interchangeably, particularly in America, where sea pens and sea cages describe the same method of culture. Generally, enclosure culture is used to describe what more precisely could be defined as cage or pen culture. Both cage and pen culture are types of enclosure, i.e. holding culturable aquatic organisms in captivity within an enclosed space whilst maintaining a free exchange of water. The two methods, cage and pen culture, however, are distinct from one another. A cage is totally enclosed on all sides by mesh or netting, whereas in pen culture the bottom of the enclosure is formed by the lake or sea bottom. History of pen culture. The origin of pen culture is more obscure, but it also seems to have begun in Asia. According to Alferez, 1977, and others, pen culture originated in the inland sea area of Japan in the early 10,920s. It was adopted by the People's Republic of China in the early 1950s for rearing carps in freshwater lakes. Later, introduced to Laguna de Bay and San Pablo lakes in Philippines by the Bureau of Fisheries and Aquatic Resources, BFAR, and Laguna Lake Development Authority, LLDA, between 1968 and 1970 in order to rear milkfish, chanos. Pens are still constructed at old pattern, except that nylon or polyethylene mesh nets have replaced the traditional split bamboo fences. The nets are attached to ports set every few meters, and the bottom of the net is pinned to the substrate with long wooden pegs. Buttressing may be used to strengthen the structures in exposed areas. Where are pens built? Pens are usually built in shallow, less than 10 meters, waters, are 3 to 5 deep, and 2 to 7 hectares in size. Although there are much larger enclosures in America measuring up to 50 hectares and up to 120 hectares or more in Japan. The areas with too much silt and decomposing organic matter should be avoided. The bottom soil should be muddy, clayey, clay loam, or sandy mud with detritus. The flow of water should be 0.2 to 0.5 meters sec. Soft substrates are preferable. Pens are formed by damming a bay, an arm of river, lake or reservoir, estuary or sea. Barriers in pen culture. There may be one series of barriers when the blind end of the aquatic body is to be enclosed. In the enclosures, where continuous flow of water takes place, there may be 2 series of barriers, one being upstream and another being downstream. Types of barriers. The barriers may be of the following types. 1. Site material dependent barriers. The barriers or dams may be built with concrete or stones, sand or soil depending upon the availability of the materials at the sites. Such type of barriers is generally equipped with screens which are made of vertical aluminum or galvanized metal bars with little spacing. Screens function to check the escape of the fish stock. Wire mesh barriers. It is an uncommon type of barrier and includes galvanized wire mesh or chain links. At the bottom of the poles or pilings underwater, such net barrier is fixed through a rope along the seabed for approximately 1 meter, until it terminates in a lead line. Generally, the net is embedded in the silt or sand of the bottom, sealing it properly, so that the entry predators and escape of aquatic culturable organisms is checked. Two. Nylon net barriers. It is an enclosure system used to partition of areas of an open aquatic body, e.g. intertidal of the sea or foreshore areas of large lakes and reservoirs. Normally, the enclosure is framed on one side by the shore and the rest 3 sides by a wall of nylon netting hung from stone on concrete walls of approximately 3 meters wide core constructed. Net barriers may be hung from steel cables tied between walls. The latter are anchored to large anchor blocks by steel cables, to check any lateral oscillation of the piles. Types of enclosures used in pen culture. The enclosures used in pen culture may be of following types. 1. Bamboo scaffolding enclosure. It is generally used in bays of Philippines and lakes of China. These enclosures are of various sizes, about 2.5 meters high and 5 to 10 centimeters wide. A gap or interspace of approximately 1.0 to 1.5 centimeters is essential between 2 bamboo splits for free exchange of water in pens. Two. Floating net enclosure. It is a type of improved net enclosure. The enclosure is held in place by concrete block sinkers with a series of small weights on the foot rope which is secured to a chain link between the sinkers. The net is kept floating by floats attached to the head rope. To prevent fishes from jumping, a horizontal net is stretched at the top of the enclosure. This type of enclosure has been proved useful for the culture of tilapia and milkfish in the lakes. Three. Single-layered pens of nylon webbing. In this type of enclosures, palmyra, a tropical Asian fan palm, poles are used for support which are pointed at one end. The size of the poles is 3 meters length, 15 centimeters wide and 5 centimeters thick. The poles are driven into the mud at about 50 centimeters and are 1.5 meters apart. A 20 to 25 millimeters thick polythene rope serves as a head rope and foot rope. Head rope is connected to a nail driven at the top of the poles so that webbing is firmly held to the poles. The laterite stones are attached to the foot rope at an interval of about 1.5 meters. The stones along with foot rope and webbing are anchored roughly 40 to 45 centimeters in the mud. The mesh size of knotless nylon webbing is about 10 to 20 millimeters, and the approximate area enclosed by such nets is up to 1.0 hectare. A scare line composed of tender leaves of palmyra is attached to a polyethylene twine at an interval of about 1.0 meters inside the enclosure, about 40 to 50 centimeters above the bed of the pen. It is because the fingerlings and juveniles may not dash against the webbing and get themselves injured. These are suitably applied as nurseries for fish or prawn seeds. Aquaculture methods are adapted based on species, environment, and resources. Create a poster, concept map on methods of aquaculture in the Philippines and their benefits.